This is Nate Deanna with Cisco. I lead our efforts around enterprise networking on the investment side as well as on the M&A side, and that also includes our Internet of Things efforts. So we actually, at Cisco, we call it Internet of Everything to make it more broad. So we have a $100 million investment fund focused on direct investments and indirect investments to help move the space forward.
So I'm Stjernfeldt. I'm with Shell Technology Ventures, which is Royal Dutch Shell's corporate venture arm. We invest, $3 to $5 million into external minority investments, in other words, startup companies that will help us speed up the development, the adoption, and the deployment of new technologies into Shell. And that is across both the traditional oil and gas industry, so finding new hydrocarbons, getting them out of the ground, transporting them and distributing, refining them, and then getting them out to our 42,000 gas station on the other side. We also do invest a little bit in clean tech. We're one of the few remaining investors who still believe there's a possibility in clean tech. And the last kind of bucket of investments we're looking at are things related to, we are 94,000 people, and there's a lot of things you can do better if you leverage IT and mobility and kind of, quite frankly, sensors, et cetera. And that's the third part of investment areas we look at.
I'm from General Electric. We started over 100 years ago on the other coast, building a different kind of network, the electrical network. Thomas Edison, our founder, really changed the way the world looked at all the processes, changed the skyline of Manhattan. When you have electricity, you can have motors, you can have elevators. It changed from a 7-story limit to the sky. And here we are meeting at the beginning, I think, of another revolution. We're looking at another industrial revolution with the industrial internet, where we're going to build out a virtual network that connects to the physical network. And we are just so excited about this opportunity. GE has many, many large systems out there powering our cities, transporting all kinds of foodstuffs and the material that makes the world run, transporting people every day on planes that carry our engines. So we're really looking forward to bringing everybody together around this industrial internet concept. We launched a consortium a few weeks ago that is focused on trying to create interoperability, and we need everybody's voice in that so that we have a smoothly working and robust network. So it's a pleasure to be here.
Thank you. I'd like to ask actually a couple questions of the audience. I'm assuming everybody saw Patrick's presentation just a minute ago, and when I say industrial Internet of Things and brownfield, you have some basis for understanding that we're talking about essentially instrumenting and analyzing a whole bunch of existing infrastructure, as well as deploying new gear into that infrastructure. I'd like to ask real quick if you could raise your hand, who here is looking for investment? Okay. Who here has money to invest? There we go. How many of you are developing or deploying products in the industrial Internet of Things space? Okay, great. So wanted just to kind of get a baseline so that as we answer the questions, we answer to our audience. As we think about the human Internet of Things and the industrial Internet of Things, with respect to, I guess in the entertainment deployment world, what we used to call the last mile of getting from a pedestal or a telephone pole to a house, in terms of the industrial Internet of Things, how do you all look at, from your perspective, bridging that gap of sensor to some way of accessing the internet or a proprietary network? Is it wired, wireless? Is it, well, I'll let you answer. What's important to you?
Well, I'll start off. There is not going to be one solution for connectivity. For example, we make jet engines. We're going to have some very sophisticated data transmission systems there. There is a huge need to be able to get real-time data from a variety of these complex systems. As more and more software becomes a part of the physical world, we need to be able to analyze this data in real time. So in some cases it will come via satellite, in some cases microwave, in other cases fiber optic, and then on short scale, Bluetooth, ZigBee, et cetera. One of the issues, though, for industrial equipment is in many cases your life depends on it, and the types of security, the guarantees around bandwidth and latency are very, very different than what we've grown accustomed to around the consumer internet. For example, I was trying to log into a website before I came up here, and there was basically no bandwidth available. That is not acceptable when you have to change a key parameter on a jet engine. So we have to think about that differently, and that's why we've brought the consortium together so that we try to make these decisions in an interoperable way.
Yes, I mean, in our case, the last mile can be pretty darn gnarly, right? We can be, 9,000 feet down under the ocean, another, 5,000, 6,000 feet down in the ground. You're 200, 250 degrees Celsius, and it's rocks and mud and stuff grinding around, and everything is moving, and it's a terrible environment. So, last mile for us may actually be kind of just acoustically couple the actual drill string in itself that you're actually drilling with, right? I wish there was a high-speed fiber optic interface down there, but there's not, right? And of course, in refineries and other locations, we have a lot of sensitivity around explosive risks and gas and those kind of things. And I think there's also a very valid point here, which is that in some applications, people's life will actually depend on these applications. And I think that's a huge difference, right? If you can't upload your latest status picture on Facebook, it sort of sucks, but it's not the end of the world, right? But if you build out an industrial application where you're monitoring for, say, H2S or something, and it doesn't work, and a person dies in the plant, that's a really bad thing, right? So it is a totally different mindset around kind of the trade-off also between bandwidth and reliability. I think it's very, very different than when I was kind of more consumer side.
Yeah, as you think about this from a Cisco perspective in networking, having compatibility between different standards is critical, and we're working very closely with GE as part of the Industrial Internet Consortium. Which I think is
Standards mean lower price, right? I like that. That's good.
Yeah, there you go. So I think that's critical. I think that being said, and also to do that, that's where you drive value. I mean, Cisco's been a big believer in Metcalfe's law, which is as the value of the network is proportional to the number of nodes squared, and that means you have to have things connect and talk together. But within that framework, there's going to be different requirements for different applications. And I think it's okay for, in some cases, you're going to pick low-power Bluetooth. Other cases, you're going to say we need a fiber optic connection. Other cases, Wi-Fi. As you're optimizing application by application and thinking about security, battery life, range, number of sensors, scalability, all those things are going to be different on an application by application basis. And I think you're beginning to see technologies emerge where you can actually pick and choose the right connectivity solution and still interoperate with other parts of the whole ecosystem. And that's going to be, I think, give us as application developers and solution developers mix and match the very best connectivity layer, the best database, the best analytics tools, and the best way to visualize that is all mix and match. And that's what's happened today in the world of IT. And I think that's beginning to emerge also in the world of what we call OT, operational technology.
So I like operational technology as a kind of kicking off point for. I kind of heard a theme almost of bespoke applications at near the endpoint. Each of you mentioned radically different kinds of applications at the end use site, and then you pushed standards farther up the stack. And so, what is the implication for where do I love standards. There are so many of them. Where would standards start to take over from the dedicated hand-built solution for a specific application? Nate, let's start with you.
Yeah, I think when we think about standards, and almost to me, it's also a question of where do you actually, where's the connectivity, where's the compute, where's the analytics? In the world of just developing these scalable systems, we've gone from all the intelligence and all the proprietary systems in one box to moving that now all to the cloud with less intelligence at the edge. To now, in the case of in IT and mobile, you have more intelligence moving back to the edge. And also we're doing the same thing where in many cases, and I'm sure at Shell, there's going to be cases where you're going to want to do a lot of processing connectivity at the edge because it's just so much data. And if you have a satellite link as an example, you just can't stream it all back. So there's going to be a lot of compute storage that actually happens at the edge, but still some intelligence distributed. And how do you orchestrate all of that is going to be actually where you could figure out where do standards play and give you flexibility at each layer to figure out what compute, what connectivity happens locally, what's in the cloud, is there middleware in there, and now you selectively move loads around depending on the use case.
Maybe us building a little bit on that. I mean, I think within Shell, we're looking at it saying that we would like to measure every single variable in every single location 24/7. That's obviously impossible to do, right? But it would be an standing value for the business to kind of hone the processes and do things better. But in order to do that, you need to actually have sensors that collect a lot of information intelligently enough on the edge to drop the ones that don't matter, and then push back up what does matter over, in some cases, quite challenged communication links, right? I mean, we are literally putting fiber into the Mexican Gulf from platform to platform to get capacity because satellite doesn't work anymore. I mean, just not enough bandwidth. But the point is then, what we really want to get to is that, some of these operations we do, an offshore drill rig is about $1.5 million a day. If we can get everything, all the different variables measured, pushed back to kind of the back-end infrastructure, get crunched on, and deliver back kind of high-quality data for the decision maker in the field, that he or she might change what they're doing and save us half a day, right? That's $700,000. That's a lot of money, right? In really small, that's what we kind of think about it. Collect everything, intelligently push back to the appropriate subset, crunch on it, deliver it back to the right decision maker in the field, which of course also has an intelligent end device, right? So it's a whole spectrum, and standardization is good. Standards usually means lower prices. We like that. That's good.
We've seen a successive wave of commoditization force. We've seen the beginning of commoditization of data. Data is still important, but the cost of the average piece of data is going to zero. We are now seeing the commoditization of the lower level knowledge. And the information age really defined the winners by who had access to data and information. But today, that access is ubiquitous. In fact, many of us have too much data, or the data we have is not of the right quality. So if you follow this commoditization trend, we wind up with some very interesting ideas. The differentiation in the future will be centered around making decisions, and to do that in a very timely and cost-effective manner, we are going to have to learn what to forget. So in the future, it will be just as important to know what to forget as to what to remember.
Wow. Okay. I think Facebook's going through that right now on the consumer side as well, from the European rulings, or Google. So I'm going to switch over to managing the onslaught of incoming data. So we've got a lot of devices. Carl, you mentioned you wanted to collect all the values, own all the values. How do you get that? How do you get
actually,
that?
Not necessarily own. That's actually a very important distinction. Hopefully we can cover that at some point. We actually almost rather want to have people like GE potentially own the data, right? Crunch the data, but then they have to take responsibility for the data as well. And that's the interesting part of it.
We're
right?
happy to do that.
Excellent. We're done.
We have $1 billion of investment going into just that, so I'm happy to hear from a good customer of ours that they like that idea. Prediction in the past was mainly a deterministic affair. You had to learn the physics. It took a lot of time, took a lot of effort, but you could work out a nice, neat equation that predicted what was going to happen. It turns out the world is not entirely predictable using those types of equations. So massive amounts of data and real-time information is needed to add to that physics-based knowledge. And that's the kind of thing we're doing at GE now with the Predix platform. Real-time data, often at the edge. In the industrial world, real-time means something that's very different than in the consumer area, where microseconds may be critical. So at that rate, even fiber optic lines can be too slow. We actually run up against the problem of the speed of light being not fast enough. So that is why the move towards smarter and smarter devices like this at the edge is actually required as the systems that sit at the edge become more sophisticated themselves.
So migrating the data from smart devices who are trying to be less chatty, less verbose, back through gateways, through hybrid public-private networks into a data center. If we talk for a second about either the investments or the product development that's going on to move data, get it from an endpoint into what we call data center ingress, into a storage or an analytic capability. Let's start on the opposite end again with Nate.
Yeah, as I think about that, I think there's terabytes, petabytes of data being created per second in many cases for some of these applications. I think there still is always demand from customers to collect more data, and I think you'll see more of that. I think as a result of that, it'll force you to push more decision-making to the edge, so you actually do filter that out much more quickly, and then only pass the most relevant data back into the cloud. And that's happening today, and I think we'll see more and more of that. I think the other interesting piece apart that is some things you might not actually have the traditional some sort of device in cloud analytics. You actually might need to have for more real-time applications actually point-to-point communication. And we're seeing now the standards emerge, whether it's around Wi-Fi or Bluetooth or other or fiber optics, where you actually do have a notion of a mesh network and actually make the decisions locally without actually ever having to go back to some sort of centralized cloud. And I think you'll see more and more of that, where you do have passive data collection in the cloud, but much more active collection and decision-making locally. And that's only going to accelerate. And then to view that data with your phones and whatnot, I mean, just like we saw in the enterprise, where you have this term consumerization of IT, where people now bring mobile devices, their tablets and whatnot into the workspace, the same thing now is happening in the OT market, where actually, why would you actually need to reinvent an entire industrial tablet when I can actually just run an app on a lockdown version of an Android device? And more that will happen, so you can actually have the operator see what's happening using consumer technologies at the edge.
Yeah, I mean, piling on that, it's not only about actually allowing them to see, it's working out. It's maybe piling on that. It's not only about actually allowing people to see it, but actually worker satisfaction gets increases when people get a chance to use a more kind of familiar, friendly, kind of tablet-like format versus some arcane, kind of mainframe-based, terminal system, right? We actually had a recent trial up in Canada where people got a chance to use a tablet to get some real-time data related to well performance, and its job satisfaction rate went up between 5 and 11%. And when they started digging into that, they realized a large chunk of that was partially because people just like to have a nice, friendly device in their hand, but also a lot of the work they did before was to go and kind of extract data, write it down on a piece of paper, and then go back to the arcane kind of terminal system to enter the data. That's not a lot of fun. So not only is it actually good, it actually increases also kind of job satisfaction, which is a key thing.
Another aspect of data is that often the context of the data is now becoming much more important than just the raw data itself. And merging one data set with another data set also has this exponential effect of increasing the overall value of the package. So in cases where that blending does create the true value, then I see a need for these data storage centers. But it depends a lot on the business model and the services you're creating. In the other cases, we will have very sophisticated types of associative memories and pattern recognition engines at the edge that allow us to process the data in real time, extract the core value, and let everything else go. And that's the forgetting part.
Yep.
So we touched on it a little bit earlier, but security through the chain. Encryption everywhere? Is that the answer? Is there a simple answer to security from the endpoints? Where is data valued? Where is it not valued? How does that work for you?
Well, security is never going to be one solution. It's going to create and require a community working together to decide how to solve that problem. Clearly, in certain areas, it's much, much more important than others. I believe it will be a solution that includes both a hardware, a software, and a network component, as well as a human factor. But that will be worked out segment by segment and product line by product line, in my opinion.
Okay.
Yeah, I agree, which is never a good thing when we're all agreeing all the time, but it makes for a boring panel. Anyhow, the point being is that, so security, of course, is crucial, right? And we have today the enterprise domain, and then we have the process domain. And when you're kind of talking about these things cross-pollinating, it's also one of those simplistic things that the business model that how security software vendors sell their products in the enterprise domain does not work in a process domain if you have thousands of sensors, right? You can't pay on a per unit, protected unit, or whatever you measure it. So it's some of these issues are actually purely as business related. How can security related solutions migrate into the process domain and find a new business model that makes sense for both the vendor and for the customer? I mentioned before actually that to some extent the solution may be for some customers that you actually allow the vendor access into this process domain, and they deal with the data, they deal with the security of it, right? They protect it, but then they're responsible for it. So if something goes bad, there's a liability issue that actually rests with the vendor, not with me as a customer, right? Which is the more traditional model on the enterprise side. You know, this is all kind of evolving, and luckily enough, we haven't had too many actually, at least in Shell's case, too many security issues on the process domain so far. But we're trying to figure out how to do this right, because we also realize copying and paste will not work, that's for sure.
I think, yeah, you're not going to find a lot of debate on the panel about security here, no question. I think, you know, traditionally security in this, especially in the industrial market, was security through obscurity, which is you have a completely separate network. Many of the client devices, the network, the processing was just separate, and that was considered secure. I think people have learned the hard way, unfortunately, that that's actually not enough to be secure. And clearly, there's other forces that are making that not possible anymore. When you think about things like the smart grid, there is value of connecting the IT network and the OT network. And systematically, you're going to see this, whether it's in your car, if you're in your Tesla, you have your telematics system and your actual transmission systems running across the same IP network. You're going to see convergence happening. It's here today. It's only going to accelerate. So therefore, you have to take a much more thoughtful approach to security. And just like we saw in IT, it's going to be layered. You have to think about what happens at the client, what happens at the network, what happens with storage security. You know, it's all those paradigms around data at rest, data in use, data in motion. You've got to secure all of those and make sure all of those work together. And then apply some sort of heuristics around not just specific policy, discrete policy decisions, but understanding the context of what's happening. And I think what's different in this world is very rarely do you see a server get hacked by overheating the fan or the processor. It's possible, but that's not going to cause a huge amount of damage. If you do the same thing in a manufacturing plant, that would be obviously a disaster in that scenario. And you're going to see security solutions that understand context, not just of who the bad guys are and what they're doing, but in some cases, turning on the fan to 100% is a good thing. Other cases, it's not. And having security that recognizes the context of what's happening, we're seeing more and more of, and clearly that's going to be the future of how you secure these systems.
Really what we have converged on is the idea that in complex systems, context is one of the key attributes. And that is what has made the human brain so special, in that we are able to deal in areas where things are not deterministic, and we can associate seemingly disconnected pieces of information to come up with a very good solution in a very short period of time. And in the security area, that's going to be required. We are having solution spaces that are approaching infinite, so we have to have new ways to approach making decisions.
One last question. The value of heterogeneous vendor solutions. So as you look at the various levels of data collection, aggregation, analysis, and moving through the system, where's the value in like multi-protocol translation? Do you expect that to be transparent? Do you reach out for specific solutions there? So, Carl, why don't we start with you?
Yeah. I mean, it's the everlasting battle, right? I mean, both Cisco and GE are excellent partners and supplier of ours, right? So, of course, there's a piece of me saying that everything should be commoditized, everything should be standardized, and I want to have every single, lowest cost provider provide every piece of equipment into our entire operations. But there's also a tremendous value of having, suppliers and partners you work with who help you assemble the solutions. So, it is really, sadly enough, one of those answers, it depends, right? If it's a pure commodity application somewhere in a part of the process where we don't really care, sure. But if it's a core in something that's extremely valuable to us, we might be looking more towards vendors like the two on the panel to kind of make it more of an integrated kind of end-to-end solution to help us get there faster.
I think we really do want interoperability. Interoperability doesn't mean that it necessarily goes to commoditization. That's probably bad news for you, I don't know. But, if you let's take a consumer example, USB. We know we can buy USB devices, plug them in, and they basically auto-configure and work. That's what I would like to see happen with the industrial internet. I would like you to be able to get equipment and plug it in to the industrial internet, and it auto-configures, it requests certain types of services, it knows what services it can push to its trusted neighbors, et cetera, things like that. How you actually affect that can be very proprietary, but the standard interfaces are there that allow you to take advantage of the Metcalfe effect and build networks of machines. So we're moving from the era where we've connected billions of people to the era of where we're going to connect billions and billions of brilliant machines. And it is really, really exciting to me to
absolutely.
be right on that edge.
I think with any complex system, initially you do have proprietary protocols because it's actually really hard to make the entire system work together. As those evolve and as you begin to standardize the different pieces, I think that's good for the market. But it still does, I think to the earlier point, it still allows competitors to now compete with differentiated solutions for analytics, for example. We think it's a good thing. We believe there's going to be 50 billion connected devices by 2020. If you now have all that data and now it's available to multiple vendors, you then allow the market to compete for who has the best analytics or the best management or the best security, and that's a good thing. And you could create a huge amount of value as a vendor there and still maintain the interoperability across the whole stack.
We have a lot of confidence that the market will select the appropriate standards rather than trying to come out with the theoretical best one.
Yep.
All right, we are out of time. I'd like to thank our panelists for their time, and it was a great discussion. Thanks, guys.
Thank you.